Okay, so this is section 13.3, which is solving absolute value equations. And this is the first day of it, and we'll spend more time on this tomorrow. So just like normal, feel free to pause this just so you guys know it looks like there's quite a few graphs. I guess there's three. And then the rest of it will just be solving algebraically. So we're going to start off with solving absolute value equations. And we're going to start off with solving graphically, and then we'll get to algebraically. But before we do that, we are going to review on how to graph an absolute value function, which is what we did on Tuesday. So we want to graph -3 times the absolute value of x minus 1 plus 2. It doesn't ask us to identify like any transformations, so we don't need to worry about that. So just like we practiced, in order to graph, the first thing that we want to do is find the vertex. So the vertex is based on your h and your k. In this case, we have x minus 1, so our h would be +1. And then we have the +2 on the outside. So remember, it's always the opposite of what's inside the absolute value and the same as what's on the outside. So we'll start with our vertex at 1, 2, which is right here. And then from there, you look at this number, which has to do with your stretch factor or your slope. So it's -3. So we're going to go down 1, 2, 3, and over 1. And remember, we want to do that to both sides because it makes a V shape. So we want to do both sides. So it looks something like that. And that makes sense because it should be more narrow since it's 3 times as stretched, and it also should be facing downward because it's negative. So now that we know how to graph, then solving graphically should be easy. So back to solving equations. So think back to like when we were solving something like 2x plus 1 equals 5. We would subtract 1 first, and then we would divide by 2. So we're going to use that same knowledge, but it's just a different type of equation. So our goal when we solve graphically is we want to set the equation equal to 0, and currently it's equal to 4. So you guys will see I have 2 red stars here on the side, which means it's important. These are kind of like your steps. So step 1 is to set equation equal to 0. Okay, so set equation equal to 0. So right now it's equal to 4. So what we can do is, since it's a +4, we could subtract it. Now I'm subtracting it from the 3 because I can't subtract it from this piece because that's inside the absolute value. And then the 1/2 is being multiplied, so I also can't subtract it from that. That doesn't make sense. So what we would have left is 1/2 times x minus 1, and then +3 minus 4 is -1. And so basically what we're asking is, when is this equation equal to 0? So we, in order to solve that, need to graph it. So the goal is to graph the equation and find what x values are equal to 0. So I'm going to go ahead and write that step down. So we want to graph equation, and we practiced how to graph on Tuesday, and then right up above. So graph equation and find what x values are equal to 0. And when I say 0, I'm talking about y equals 0, or in other words, like this x-axis. So we are going to go ahead and graph it. So based on the equation, the vertex would be 1 because it's x minus 1, and then the outside's -1. So remember, we look at this, and it's the opposite of that, and then it's always the same as this. So 1, -1. So I am going to kind of zoom in here. So 1, -1 would be right here. Now for the next part, we look at our a value, which I'm circling. It's 1/2. So I'm going to go up 1 over 2 and put a dot, and up 1 over 2. Now really, you just want to keep extending your graph until you reach the x-axis, because that's like your 0. So when we say we want to find when it's equal to 0, you're actually like finding your x-intercepts. So technically, it's equal to 0 here and here. So you're just kind of figuring out what those numbers are. So I know that this number right here is -1, and this one right here is 3. So your answer would be x equals -1 and x equals 3. That's when it's equal to 0. So that's kind of like your learning one. Now let's do another one together to hopefully kind of solidify this. So we are going to start the same exact way. So we have -2 times the absolute value of x plus 5 plus 4 equals 2. And we want to set it equal to 0 based on those red stars that we have up above. So to do that, I need to subtract this 2 from both sides. So then we would have -2 times the absolute value of x plus 5, and 4 minus 2 is 2, and this is all equal to 0. So the next step after that would be to find the vertex. So to find the vertex, remember we look at this piece, and it's always the opposite of what's inside. So that would make it a -5, and then it's the same as the number on the outside, which would make it a 2. So we would go to -5, so 1, 2, 3, 4, 5, and then down 2. -5, and I actually did -5, -2. I want to do -5, +2 up here. And then from there, we look at, I'm circling it, this a value. So that a value is your slope, and it tells us we're going to go down 2 and then over 1. And remember, we want to do that on both sides because we're making a V shape. Now, I could continue to go and make another point, but really, we only need to go until we get to that x-axis because we're trying to figure out when it's equal to 0. So it's right here and here. So we can kind of count and figure out what those numbers are. And it looks like it's at -4 and 6. So x would equal -4 and x would equal -6. So that would be your final answer. So this is one method of solving. You do need to know both methods. And so if I just tell you that you have to solve an absolute value, you can pick. But if I tell you using a specific method, then you would need to. Kind of like when we learned systems of equations and you needed to know the different methods. So our next method is solving algebraically. We are just looking at 2 examples. So this is definitely the preferred method because you don't have to graph, right? So our goal with this is to isolate the absolute value bars. So that's your first step. So isolate the absolute value bars. So what I mean by that is this piece. Think of that as like your variable. We want to isolate that variable or those absolute value bars. So if this were something like, if I were to rewrite this, I'm going to take this entire thing and just call it x. If this were 2x minus 4 equal 2, I know that I would add 4 first and I would divide by 2, right? So I'm going to do that same thing. So I'm trying to get those absolute value bars by itself. So I'm going to add 4. So notice we're kind of doing the opposite of what we did for solving by graphing. So then this would be 2 times the absolute value of x minus 5 equals and then 2 plus 4 is 6. And then I'm trying to get those absolute value bars by itself, so I'm going to divide by 2. So I get x minus 5 equals 6 divided by 2, which is 3. Okay, so at this point, you have isolated the absolute value bars completely. So this is the tricky part, is you actually split and create two equations. So I'm going to go ahead and write that down for my next star, and then I will explain it. So split and create two equations. So I know that the absolute value of -3 could equal 3. I also know the absolute value of 3 could equal 3, right? So that means that there technically would be two possible solutions, because this entire thing that I just highlighted, that entire piece could either be 3 or -3, because I know the absolute value of -3 is 3 and the absolute value of 3 is 3. So that's the reasoning behind it. Now, for a lot of you, you don't really care why it works and you just want to know the memorization. So once you get to this piece, you just split it, and you are going to create one equation that's equal to the positive number and one equation that's equal to negative number. So basically what that's saying is whatever is inside could be +3 or -3. And then you just solve it. So I'm going to add 5 to both sides. So in this case, x would equal 8. And then I'm going to add 5 here. So -3 plus 5 would be 2. So you have x equals 2 and x equals 8. All right, so we are going to look at one last example. So the first step, like the one that we just did, is to isolate those absolute value bars. So I'm going to go ahead and start off by adding 2 to both sides. So we get 3 times 4x minus 5 is equal to 21. And then from there, I'm going to divide by 3 on both sides. So I would get the absolute value of 4x minus 5 equals 7. So now that I've isolated the absolute value bars, in order to get rid of them, this is where I split and create two equations. So one of the equations will be 4x minus 5 equals 7, and the other equation will be 4x minus 5 equals -7. So we're saying that this piece, or whatever is inside here, can either be a positive or negative, and we'll still get 7. And then you solve. So we add 5, so you solve both equations. And so you would get 7 plus 5, which is 12, and we divide by 4, and we get 3. And on this one, we add 5, so we get 4x equals -2, and we divide by 4, so x equals -2 over 4, which is really -1 over 2. So you have two solutions. So some of you might be wondering, are we always going to have two solutions? The answer to that is no, and that's actually what we're doing tomorrow.